Right, welcome to question 3 of the 2018 mock for year 13. Question 3 is again about dissociation constants. This is the ionic product of water. We're given ionic product water at 10 degrees C. Knowledge question to start off with. Which is the correct expression for Kw? Well, it's C. It can't be D, as was questioned in class, because the concentration of water in water is always going to be approaching 1. The dissociation into H plus and H minus is so tiny that the concentration of water in water would obviously be 1, and it declines slightly because of this dissociation, but it's effectively 1, so if it's 1 we can get rid of it, and so that's the accepted expression for Kw. Calculate the pH of pure water at 10 degrees C, give your answer to 2 decimal places. So if that's Kw at 10 degrees C, 2.93 times 10 to the minus 15 equals concentration of OH minus and concentration of H plus, right? And we know that water dissociates like this. So this and this have to be the same, so effectively the concentration of H plus will be the square root, 2.93 times 10 to the minus 15, which gives you a concentration of that, and then if we do the negative log of that, will give us the pH 2 dP we were asked for. Why is pure water at 10 degrees C not alkaline? So there's a clue. If we didn't get an answer of greater than 7, we've gone wrong, because it's saying, or it's implying from the question it's alkaline. Well, okay, that's a knowledge thing really, but it's not alkaline, because to be alkaline we'd have to have concentration of OH minus greater than the concentration of H plus, but of course that can't be possible because dissociation happens like that. Cut a long story short, concentration of OH minus is the same as concentration of H plus. Calculate the pH of a 0.0131 moles per dm cubed solution of calcium hydroxide at 10 degrees C. Give your answer to 2 decimal places. Right, so first thing that we need to do is we need to calculate the concentration of OH minus ions. Once we've got the concentration of OH minus ions, we can go use the Kw of water to work out the concentration of H plus, and once we've got the concentration of H plus, we can do the negative log to find the pH. So that's the battle plan. The first thing we have to remember from, like, I don't know, year 8 is that that's the formula for calcium hydroxide, because it's in group 2, and hydroxide ions are OH minus. Right, so if we've got a 0.131 molar solution of that, so the moles of OH minus will be 2 times 0.0131. Then we're going to plug that into concentration of OH minus times the concentration of H plus equals whatever it equals, which was 2.93 times, what goes there? 2.93 times 10 to the minus 15, so square root of 2.93 times 10 to the minus 15 equals I'm talking about 2.93 times 10 to the minus 15 over 2 times 0.0131 will give us a concentration of H plus. Okay, and then we're going to negative log it to get the pH. That's my son. Give the answer to 2 decimal places, don't forget that. Right, the 0.0131 moles per dm cubed calcium hydroxide solution was a saturated solution. Okay, so that was as much calcium hydroxide as we can dissolve in water. A student added 0.0131 moles of magnesium hydroxide to 1 dm cubed of water at 10 degrees C and stirred the mixture until no more solid dissolved. Predict whether the pH of the magnesium hydroxide formed at 10 degrees C is larger than, smaller than, or the same as the pH of the calcium hydroxide solution at 10 degrees C. So this piece of information tells you that I can't get any more than calcium hydroxide dissolved. Okay, and we know that the pH of that was that. So what the question is really asking you is, can we get more magnesium hydroxide dissolved in 1 mole than we can get calcium hydroxide? So this is a question about group 2 solubilities of hydroxides. Right, now if you feel that magnesium hydroxide is more soluble, then more will dissolve than calcium hydroxide, and its pH will be greater. If you think that less magnesium hydroxide will dissolve than calcium hydroxide, then the pH will be lower. Okay, so go to the group 2 stuff, group 2 inorganic, year 12, and have a read up of solubilities of group 2 hydroxides.